Hi everybody, I'm Wes McCall with Geoprobe and this is Dan Pipp. Today we're going to talk about the SP22-ISP. That's Isolated Screen and Pump. So today we'll be using this 1 foot long wire wound stainless steel screen. It comes with a screen head. The screen head adapts to the head of the screen and allows us to attach to 3/4 inch PVC. Okay, this seals, and then this will go into the PVC and hold our pump in place. All right, I'll lay this aside. We also have a 4-foot stainless steel screen, as Dan's showing you here, and of course the grout plug on the end. So if you need to sample over a longer interval and you want to use stainless steel, you can use the stainless steel screen here. Then we have a PVC, 15-inch PVC screen. We also have a PVC head to use with that screen. These are 10-slot screens, so a little coarser slot. And then Dan is going to hold up our 5-foot PVC screen, also 10-slot. Again, we could attach that screen head and a point to the end, and we could use the PVC screens. Okay, a little bit why we want to use this system. One of the things that's nice here, as we saw just a minute ago, is that our pump goes into our PVC and there's a seal on our pump head. Here's our pump with our inner sample tube attaching to the barb fitting on top, pump body, and our seal. And this seal goes into the PVC, goes in, and the O-rings on that seal against the ID of the PVC. And then our screen and screen head threads on and holds that pump in place. So this locks the pump in place and provides us with a seal inside, okay, so water doesn't go inside the PVC. Then our screen head here seals inside the expendable point to prevent water from coming into the annulus of the point or going out, okay. So the point is, when we have everything in place, we're sealed, water can only come into the system and go up our sampling tube that's from the formation. We won't get water from the rods or the PVC into our sampling system, okay? So it provides this high integrity. The sample only touches the screen head, the pump, and the sample tube once it leaves the formation. So this gives us a good high integrity sample. We think this will be very important for PFAS sampling where our detection limits are very low and we need good quality samples. Also, this could be really good for chlorinated VOCs or BTECs. Again, minimum contact with the tool steel and the PVC will provide us a higher integrity sample. Also, some analytes like hexavalent chromium or arsenic are redox sensitive. So you don't want that to come in contact with the steel of the rods because that will change the redox potential of the water, and those redox sensitive species can change and you might not get an accurate sample. So protecting sample quality, getting a good representative sample is the main emphasis of this system here. Now, just a little bit about our pump. We have a service kit for the pump. So you have all the accessories, extra springs, extra O-rings, and other parts you'll need as you use the pump in the field to replace parts like the O-rings and springs, okay? And then of course you're going to want to decon the pump between uses, and we have a set of brushes specifically to use for the bladder pump or the mechanical syringe pump to clean the pump between uses, so you can decon and be sure you have a clean pump going down hole. Now of course our expendable point holder will go on the end of the rod, and expendable point with O-ring will go in and seal. We're also using O-rings here on the expendable point holder, and then you'll see us use O-rings on each rod joint. We'll drive it in, then we'll add the O-ring and add the next rod. Okay, so we'll go through that process in a few minutes here. Before we put tools in the ground, we need to understand the subsurface geology and where we can successfully sample. In zones where we have high electrical conductivity and high HPT pressure, that generally indicates low permeability, fine grain formation. So we need to have low HPT pressure and low EC most of the time, so we know we can get a good sample recovery. So with the HPT log, we look for these low HPT pressure and low EC zones to indicate sandy zones in the formation. Down here, we have a pretty good sand zone from about 32 to about 42 feet. Okay, so we have low EC and low HPT pressure. And then around 41.5 feet, we see the electrical conductivity goes up and our HPT pressure goes up, indicating there's a clay layer there, a fine grain layer there. So what we're going to target today is setting our screen at about 41 feet and then sampling the zone from about 40 to 41 feet. Okay, now if you don't have an HPT log, please use your boring log from a nearby location. You really need to understand the subsurface before you try to put a groundwater sampling tool in to collect your sample. Sampling blind is not a good thing, because a lot of times, you know, if somebody says, okay, let's sample from 44 to 45 feet, we're in high EC, high HPT pressure, we're in a silty clay. You're not going to get any water out of that baby. Try to target those sandy zones. That's where you can be successful sampling with these tools. Okay, a little bit about the pumps. We talked a good bit about the syringe pump and showed you that. We also have a mechanical bladder pump. Now, the syringe pump is designed so that it has no Teflon components. And the syringe pump is really targeted at being able to use it for PFAS sampling. That's the polyfluorinated alkyl substances that have gotten to be quite a concern recently. So the syringe pump is really good to use for PFAS sampling because it's designed with no Teflon components. Now, the mechanical bladder pump will look almost essentially the same, but it will have a bladder inside instead of the piston. We have both Teflon bladders and polyethylene bladders. If you're going to sample for PFAS, you definitely don't want to use a Teflon bladder. Polyethylene may work, but still not on the real big happy list for PFAS. But if you're sampling for volatile contaminants, the bladder pump may be the preferred pump for you to use. The bladder pump is better for VOC sampling because you have lower loss of VOCs during the sampling process with the bladder pump. Okay, so the syringe pump is good for PFAS sampling. The bladder pump is better for volatile sampling. To make this a little easier in the field, we have a finger rack here that holds the PVC in place. And the finger rack is really nice. We're using HDPE tubing, a high density polyethylene. This is what you'd probably use if you want to sample for PFAS. You could also use this if sampling for VOCs, okay? But the tubing is kind of stiff, and so if you try to pre-string the sample line through the PVC is not going to want to stay in place. So the finger rack keeps things in place, and often we'll put a bungee cord across it while we're stringing in the sample line, so it behaves nicely and the sample line strings up easy. You can also see over here by Dan, we have a little arm to hold a rack of tubing, so you can string out the tubing and measure it, make it easy for you in the field, and then string the tubing through the PVC. Now, before we start putting tools in the ground, I want to mention health and safety. We're working in level D safety gear here today. Steel toe boot, hard hat, hearing protection, safety goggles. We'll be putting those on in a minute before we start working with the tools. So please use proper safety attire for the project you're working on. Okay, so we have our expendable point holder and our expendable point with O-rings installed on our 2 1/4 inch probe rod. So now Dan and I will start advancing tools to our target depth of 41 feet. All right, thanks Dan. And also notice we're using our rod wiper here. The rod wiper will drive the tools through it, and then when we trip it out, the rod wiper will put the weldment over it, it'll hold it in place, and the rod wiper will clean our tools as they come out of the ground. At least clean the tools of gross mud and goop, okay? So today we're using the 7822 machine to advance the tools. We're going to check our tool string and get it leveled up good so we're plumb with the ground surface. So now I'm fishing an O-ring out of my pocket so we can put O-rings on the rod joints here. And Dan will make sure the female end of the new rod is wet so we don't damage our O-ring as we install the new rod. There we go. Okay, so now we have 8 rods in the ground. We're using 5-foot rods. So with the stick up, we have 40 feet of rods in the ground. We're going to check our total depths and see if there's any fluid or anything in the hole with our little water level indicator. So this is our old water level indicator here. And probably as you can hear, it beeps when we hit the water. So we're going to lower down, check our depth, and make sure we have 40 feet of rod in the ground, and check for any fluid in the rods. Okay, so we got a little beam there, and we're right on the bottom of the hole. So I think we got a little mud on the bottom of the hole. Let's check our TD. Okay. And that is 40 feet plus the stick up of the point there. So it looks like we've got about 2 inches of fluid in the bottom of the rod. Not too bad. Our O-rings are doing a pretty good job. Okay, so we are where we thought we were. Now we'll add our next rod and advance to 41 feet. And we'll mark the rod so we can be accurate with our depth. Okay, now, so we've added our last rod, and we're going to measure from the rod joint up 1 foot and make a mark. Let's see if I can get that about there. So this will take us down to 41 feet, our target depth here. So what we're doing here now is we're setting up with our rod wiper weldment, and we'll put on the rod grip so we can grasp the rod and be prepared to pull it out. Okay, so I'm just installing the rod grip on the rod so we can pull the tooling out when we're ready. So now what we'll do is we have the screen assembled on our PVC, and we'll lower the screen in PVC down hole and get the screen set on the bottom of the expendable point holder. Okay, so I just wanted to re-emphasize the pump assembly here. We have the sample line attached to the barb fitting on the top of the pump. Okay, the pump body, and then our seal witch down here with the 2 O-rings. We do use an Oetiker clamp here to make sure our sample line doesn't come loose, okay? So then the sample line is pre-strung through all of our PVC, And so when I install this, these O-rings will seal against the inside of the PVC, giving us a good seal here. So we have our screen head and our screen, our adapter, screen adapter to adapt our stainless screen, to adapt our stainless steel screen to the PVC. And I have to push in a little bit, and that will push that seal wedge up into the PVC ID and seal that in place. Okay, now again, today we're using our 1 foot interval stainless steel 4-slot screen. Okay, so now we'll just lower this down our rod, and Dan will work the PVC sections over to me and we'll install this in place. The screen will lower down and rest on the back of our expendable point, and at that point then we'll retract the outer rods and set the screen in the formation. Okay, thank you, Dan. Okay. There we go. And of course we have O-rings on each joint on the PVC. It's really good to do this process with at least a 2-man team in the field. And of course we're going to set this, and at 41 feet we're going to be somewhere between 20 and 25 feet below our static water level. So we're going to have a lot of hydraulic pressure in the formation pushing water into the screen. So you have to hold down pretty good on the screen in PVC sometimes to get this to stay in place as we track the rods. Okay, there we go. Okay, we just have a short section of PVC here, so we can be sure we have enough to hold the riser in place as we trip the rod back and set the screen in the formation. Okay, so we'll start. Dan will hold down on this as I slowly pull the rods back. We'll set the screen in the formation. There we go, points out. Gonna have to hold down on this baby. There we go. So now we have the screen set in the formation. So Dan's going to remove now what's an extra section of PVC, so we don't have to trip the rod too high in the sky. We'll just lean it over, slide off our rod and our PVC. So now we have the electric actuator in place to run the pump down hole. We did pump a little bit manually, and Dan, why don't you point that in our bucket? And so you can see we have pretty muddy water right now as we just started. We've disturbed the formation a little bit as we put things in. So now we'll attach this to the actuator head here. We have a couple of little split bushings to hold the tubing in place. So, okay, so now we've got the bushings in place, and we're using this little knurled nut on top to lock that down. And that bushing bites on the tubing and holds it in place here. So now before you run the actuator, before you attach the tubing, you need to make sure the actuator is at bottom of stroke. Otherwise you'll crimp the tube when you try to run it. So we have our actuator at bottom of stroke now. We're attached. Let me get my inverter connected to my power supply. And there we go.
Ready?
Okay, go ahead, Dan. It's turned up to about 3. Okay. Okay. So we'll check flow rate for you here. This is a 500 ml plastic beaker, and we'll just use this to check our flow rate.
1, 2, 3, go.
Okay, so we're timing. We're just going to check our flow rate here. We're at a setting of 3. This is about half speed on the pump. Roughly 60 cycles a minute, about 1 cycle a second. 55, 58, 59, stop. Okay.
450.
Yeah, we're just probably a little over 450 mils here, so good flow rate. And it is starting to clear up. I'm going to put this in our container. So let me rinse this a little bit again. We'll see. Well, this is not very clear. You can at least see maybe that the water we're getting now is not quite as turbid as the initial water we had. And then we'll let it run for a little bit and come back when it clears up in a few minutes, or at least clears up more, and collect our samples. Okay, so now we've purged probably a little over 2 gallons of water. You can see the early water was very turbid. We increased the pump speed probably over 600 mils a minute for 3 or 4 minutes, and then turned the pump speed down. That kind of helps surge and develop the formation. So now we're getting much clearer water out. And Dan is going to come in and fill a couple of VOA vials here. And we'll take a look at those VOA vials. All right, you want to do that? There you go, Dan. And then I can hold the tube when you're ready.
Go ahead and hold the tube.
Okay, yeah. All right. We're going for that 0 headspace.
Of course.
Now here, let me hold that up here with a little grass on it. Okay, and there you go. So now you can see the clarity of the sample. If I get the grass off the vial, it'll probably look a little nicer. And Dan is going for our 0 headspace. So you can see now we have pretty low turbidity samples, probably somewhere in the range of 10 to 20 NTU. So we've been able to get good clarity with our samples here. Dan, you go ahead and hold those and show those to the folks there. There you go. Yeah, put your glove behind it so they can see your glove through it. So in the neighborhood of 10 to 15 minutes of purging here. I've turned it down now, so it's probably around 250, 300 mils a minute, which is still kind of high for VOC sampling. You might actually want to turn it down further. You might even get greater clarity water if you do that. Okay, so now we're kind of done with our purging sampling here. So we'll take off our actuator and then we'll start tripping out our PVC and screen. Okay, Dan, you want to go ahead and stop that at bottom of stroke for us? We may have to pull the rods up to loosen the screen and the formation before we can trip the tools out. Sometimes the screen will lock in the formation, especially after we surge and purge for a while. All right. So now we'll pull this up a foot or so to break the screen loose, and then we'll trip out the screen. We'll pull it up enough so we can grab the next rod with the rod grip without any problem. All right, there we go, and down. Okay. So what we're doing now is we're adding clean water to the annulus of the rods. This way, when we pull the screen, we won't have formation heave into the rods. And then we'll be able to grout through the annulus of the rods bottom up as we retrieve the tools. So we filled our rods to the surface, and now our screen is coming loose, and we need to add more water, please, Dan, as we pull the casing out. Because as we pull, it acts like a syringe and wants to pull formation into the end of the rods, and it's stuck. There we go. Okay, there you go. Right, then I'll let you get some more water, please, and continue adding water as I pull this up. So we need to keep our head positive as we take this out. That's good for now. Now we'll take off this upper joint casing. It's a little tight, Dan. We snugged it up pretty good when we put it in there. Okay. Alright. So I'll wait for Dan to add a little more water as we continue to pull the riser. Okay, grab some more water, Dan, please. Oh, there we are. Okay, so Dan has worked with me to trip off our PVC riser incrementally, and now we're pulling the screen out. Okay, so here now we're recovering our last PVC, our screen head, and our screen, and we can disassemble this. Okay, I'll lay this aside to be cleaned up. Dan will push out the pump for us. There we go. So again, here you can see our pump with the seal on the end that seals in the inside of the PVC. Our pump body where our tubing is attached with a crimp here on our barb fitting. So we recover our system that provides a sealed, isolated sample from the screen interval. Thank you, Dan. So now we'll check total depth on this and see if we're open to the bottom. And if so, then we can do trimmy grouting and grout out as we pull the tools. Okay, so now we have the screen and PVC out, and I've lowered my water level indicator, and I'm checking bottom here, and I want to see if I'm open, and I'm actually reading just a little over 40 feet. We retracted the rods about a foot or two, so we're probably open a little bit below the bottom of the rods here. So now we can pump in grout with our trimmy tube and grout tooling out and have a good grout seal.